All right, again, let's get started. Good morning again. So today, the very first talk is about introductory talk on the global perspective of energy and also Indian scenario, and then the importance of biofuel, making ethanol from ag waste, agriculture waste. Okay, you can hear me okay? Yes, sir. All right, so that's a talk on current status of energy and bioenergy in the world in India. Okay, let's see the next slide. All right, someone can move the slide if if it's not working. Yeah. All right, next slide. Okay, it's not working. Yeah? Okay. Okay. All right. So let's get started. Sorry about the technical glitch we're having. If you look at the world population 1,500 years ago, it was only a very small amount of people live on the earth, and most of those population concentrated on in India and China and Western Europe. Okay, 160 million people globally. Um, yeah, next slide. Next slide, please. The, yeah. Okay. Next slide. Click one more time. Yeah. So if you look at the population growth in 2022, the world reached 9.8 billion people. In 2050, we'll reach close to 10 billion people. As a result, we have put the crisis on energy, food safety, environment, and uncertainty. Okay. So if you look at the increasing demand for food and fuel, which is enormous to support the people that we are going to have in 2050, close to 10 billion people. Okay. Um, I'm going to make sure this everybody gets a slide. Okay, so it's too many slides to take notes. So maybe take important highlights, but everybody gets the slides. Okay. So let's look at the world energy consumption. So from 2022 to projection of 2050, there are two kinds of countries. One we call Organization of Economic Cooperation Development Countries, which are the 30 Western European countries and the US. The rest is the non-OECD countries. You can see that different energy that is increasing from conventional gasoline to biofuel, green energy. The projection is more towards green energy compared to the two different kinds of the world of Western European country and Asian countries. If you look at the lower panel, you can see the different kinds of energy resources that we've been using from 2020 to 2050. You can see the projection of renewable energy is going up, the green line. Okay. So the nuclear is going a little bit, but there is going to be a decline in gasoline production and gasoline consumption. That is a good sign because we need to have green energy to, mitigate the problem that we have in environmental, disasters we are having. So the China energy demand is high. And then U.S. comes next, and then India stands on fourth after Western European countries. Okay, next slide, please. So if you look at the different energy that we've been using resources, we still depend on oil and gas. Okay, 31% of energy needs of all the global people is coming from oil, and 21% is from natural gas, and coal is 29%. We are going to focus on the biomass waste of 10%, which is our biofuel production sources. There is also, of course, nuclear and other renewable sources of energy. Okay, next slide, please. Next slide. So if you look at the problem of using petroleum for our energy source, of course, that's going to cost the production of CO2, and the CO2 levels keep going up in the atmosphere from around 300 ppm to currently 450 ppm of CO2, and that, as a result, and you already know that causes the climate change and global warming. And the annual CO2 production from fossil fuels, if you look at different countries, right now, China and India are using, the population growth is putting down that they are emitting more CO2. China is number one. And then, India is also up there. US used to be the main producer of CO2. Now, China takes over. Next slide, please. Okay. So when CO2 goes up, then we are going to have a problem of, environmental problem. For example, polar ice is melting, frequent flooding of, mega metropolitan cities like New York had a big flood, and coastal erosion, increase in coastal erosion into the land. And so these are problem of increase in atmospheric carbon dioxide concentration because of fossil fuel use. You can see the increase in total greenhouse gas emissions. And if you look at country-wide breakdown, per capita energy emission, because of Saudi Arabia is less populated than China, Saudi Arabia stands high because they're more affluent. They have energy they burn, and as a result, their emission of CO2 per person is high than China. But overall, who produces more as a country? China is number one. So if you look at global gas emission again, you can see the figure here. 65% is carbon dioxide, and then we have methane and nitrous oxide. Those are the greenhouse gases we're talking about. And on the economic sector, global gas emission by sector is agriculture and electricity generation produce more CO2 because we still use coal power generation. So we're producing a lot of CO2. And then transportation and industry and other sectors contribute to CO2 production. If you look at the example of COVID years, when everything shut down, You can see the data on CO2 level globally. It went down that period that we shut down. So there is a direct evidence correlation. When you have less emission, you can see less CO2, and that was shown here in this figure. When we shut down, the CO2 level went down globally. Okay? If you look at the Energy Institute in US projection, they project 50% increase in world energy by 2050, mostly led by renewable energy source. It includes wind, solar, biofuels. Okay, and that's a different sources projection from all the way to 2050. Okay, that's a good sign. People are realizing the importance of renewables, and India is one of the leading one in terms of solar and wind. They're making a big stride. And again, more statistics on world electricity generation by source. The projection up to 2050, solar going to be the high. And then you can see the natural gas and conventional energy is going to plateau out and go down. Okay, that's a good sign. People are realizing the importance of renewable energy. Okay. And if you also look at world net electricity generation by source, you can see this bar diagram. You can see coal is going to go down and solar keeps going up. Okay. And then you can also see the other, in this case, the biofuel source coming up. Okay. So all the projection by Energy Institute administration show, information administration show that the conventional energy sources in the projection is going to go down. That's a really and the importance of producing biofuel is more needed. Okay. So here let's look at everything tied to the gasoline price. Okay, how much a barrel of oil cost. Okay, so here's a look at the information of the gasoline price, the Western Texas crude oil price from 2022 to 2026, 27 projection. If you look at the median level, it's at $70 to $80 a barrel. And the range, they're projecting the range, it can go up to $120, or it can go down to $40, $50 based on geopolitical event. Right now, oil price went up because of the problem of Israel and Iran attacking each other, and the oil price going up. Okay. All right. Oh, yeah. Can you move that up? It's not moving now. Let me see. No. Yeah, it's going now. Okay. Let's look at this, the same projection of natural gas. Okay, the natural gas price is fluctuating and plateauing out, and the projection can be a wide range of projection of price of natural gas. Okay, so when we talk about green energy and everything is tied currently to oil price, crude oil price, and gasoline price. Yeah. Here's again more statistics on different energy source from bio and hydro energy production, nuclear, wind, solar, battery storage, gas, compressed gas, coal, and oil. Okay, so look at the last 2 years in the U.S. Most of the energy storage is improvement is located battery storage, improvement battery technology, and you can see less and less on oil and gas, okay, and coal. Okay, so that's another sign of renewable storage make up most of the power in the U.S. grid in 2020. Let's look at China's green spending. China is spending a lot of money, and if you look at the renewable energy in China, especially solar and wind, they are really increasing. And then comes China, and then comes U.S. And then you can see India is, I'll say, in top 6, top 7 position. So India is making great stride in the solar and wind energy production. Another statistics here to look at total energy consumption by, different sector. Who is using more energy? Okay, we look at the industries, transportations, and residential. Okay, those are the areas that we are projecting to need more energies. Okay, so transportation, of course, currently mostly depending on liquid fuel. Okay, let's look at primary energy worldwide. Uh, the darker blue concentrated on more energy users are China and US, and India is right there. India's energy use and demand is going up because of population increase. And the annual change in primary energy consumption, they are predicting some of the countries going to need more energy than currently they're using. Some of the countries going to go drop. For example, look at Nepal. Nepal energy demand going to go down in minus 10%, whereas India's energy demand going to go up to plus 10% in the future. These are based on population growth and economy, and people are moving up. Their mobility is high, and the energy demand is going to be high. Everybody going to have more air conditioning in every room, and that's going to have more energy consumption. Okay. So those are all projection of up to 2050, 2050, how much energy each country going to be looking up from current level to plus or minus. Another statistics to show energy consumption by source. You can look at here. Right now, more energy is conventional energy, oil and coal, and natural gas, and then you're going to have the biofuel, which is we're going to talk about, and solar and wind is picking up. So that's from year 1995 to 2021. You can see there's a little bit drop in oil and coal, but they are the conventional source of energy worldwide. Look at another statistic, look at per capita primary energy consumption by source. You can look at the different energy with different color code from coal all the way to solar and other renewables. You can see the increase in that red line with the other renewable energy source in the US. And look at India. India is also increasing in other renewables other than coal and conventional energy source. Okay, so if you look at all the statistics, the conventional energy source gradually going to go down. So we're going to have, depending on more renewable and green energy in the future. Again, I took another statistic from global energy consumption from 2000 to 2020. You can see the coal negative 0.6% per year going down, coal use. Oil is negative 0.5%. And natural gas use went up 2.4% every year. Nuclear is going up. Hydroelectric power is going up. And renewable is really going up 14.1% because we didn't have renewables before. So you can see a big jump in renewable energy source. So those are last 20 years data to show which energy sector is a negative growth, which energy sector has positive growth in energy production. So let's look another way to look at demand per capita of energy from year 2015 to 2021, and you can see the year. There is not a big difference in most of the countries, in Western countries, between 2015 to 2021. There is no big difference, but China and other countries, there is big difference. That's the reason, again, population increase and demand and people, economic conditions improving, their demand is going up in terms of energy. It is directly tied to the more energy you consume, the more CO2 you're going to produce. Okay, so that's again, the year 2015 to 2021, the amount of CO2 production. Most of the countries level up, but some countries it's going up from last 7 years. So the good news is that some of the countries are turning into solar, and you can look at the year 2015 to 2021, a big jump in solar in Australia and Japan, and also in India too. We have a big jump in solar production, energy production. So let's look at top oil producing countries in the world. US is number one currently. They produce 16 to 17 million barrels every day. So the US line is that blue line, oil production in the world. And the second is the green one, which is Russia, and then Saudi Arabia, and then Canada and Iraq. These are the top oil producing countries in terms of amount of oil they produce every day. It's from 14, 15 million barrels every day in the US. So US is going to run out of oil soon because they're extracting as if there is no tomorrow, okay? But they're soon going to be run out of oil. So let's look at these total reserves of energy and annual demand for energy, okay? So, of course, solar is the best energy source that's really available, plentiful. And you can see the annually how much energy is produced from tidal wave all the way to wind. And you can look at the energy potential. A lot of coal still there. And then you have uranium for nuclear, then oil and natural gas is going to run out soon. Okay, so these are the on a global scale, how much energy is still there, how much energy is being annually used in terms of the reserve we have. Okay. Another way to look at energy consumption in the US in terms of quadrillion British thermal unit. Again, the same trend is happening. Conventional energy source is really high, but we are keeping up with the biofuel hydroelectric, which is the recent phenomenon. And this trend is keep increasing. We are now slowly moving to renewable energy source. This is another way to look at annual existing and expected renewable diesel production capacity in the U.S. And you can see that there's a planned capacity and existing capacity. The planned capacity is increasing, and the government is putting more money into. Past government put more money into improving the renewable sources. And if you look at the production of biofuels and sustainable aviation fuel, again, U.S. is putting, in the past, government put more money into it. As a result, they're producing more sustainable fuels and also jet fuel for, for airplanes. There's another statistics to look at overall picture of energy. Petroleum, of course, is a dominant one, followed by natural gas. And then we have all the equal amount of nuclear, coal, and renewables. Okay. If you look at renewables, it's a big variation from wind, solar, geothermal, biofuel, which is biomass, including agriculture waste. So all of them together, we are giving 9% of energy from these renewable energy. And this is to just look at most of the energy that we produce goes to transportation, right? 28% energy demand is, running your car, running airplane, running, trains. Then comes industrial sector, and then residential, and then commercial. So these are the energy demand by sector. So we still, even though we have increase in electric car production and use, we still need liquid fuel. Okay, so we need to have some form of liquid fuel other than gasoline. So that's why ethanol and biodiesel come into picture. This is to look at different energies from renewable to coal all the way down. And I can see every year by year, the renewable keeps going up. So there are a lot of statistics to show you guys the conventional energy source level is going to plateau out, slowly go down. And then the renewable source of energy going to keep increasing. Okay. This is a solar energy. That's a good picture. You can see that it keeps increasing. Solar energy capacity worldwide, it keeps increasing. every year by year, there's a big growth in solar energy production. And you can see before Kyoto Protocol, after Kyoto Protocol, the energy consumption per capita, you can see in the U.S. it's going down the CO2 production. So the government and globally try to reduce CO2 was working until the new government come in, and we don't know what's going to happen in the U.S. And again, just to show annual U.S. electricity generation by various sector, currently it's still dominated by conventional one, but the renewable one is also coming up, increasing by 21%. Okay. So that so far that section, I'm just giving you a global perspective of where we are. Okay. So the take-home message is here: we are still dependent on conventional energy. It's a coal, petroleum, natural gas. All right. As I said, at some point we're going to run out. There's only finite resources out there. In the U.S., we are predicting we're going to run out of gasoline, oil, because we've been extracting oil very, very fast, and it's going to run out soon. So we need to find alternative ways of sustaining our lifestyle by producing different energy sources. So let's look at Indian point of view. I got a lot of statistics in India. I got information from the Center for Sustainable Growth from India, from Lucknow. Okay, we'll look at how India is addressing the greenhouse gas and climate change, and what kind of input they're putting in emphasis on renewable energy. Okay. So again, we know the more we burn conventional energy, we're going to increase CO2. As a result, we're going to increase the climate change and especially global warming. We already know that part. If you look at India government, it is the government determined target, NDC target for each. They wanted to reduce emission by 33 to 35% from 2005 levels to 2030 level, 2030. Okay. And they also want to achieve 40% non-fossil fuel power capacity by 2030. Okay. They want to create 2.5 to 3 billion tons of CO2 sink by producing more trees and forests, planting, reforestation. And they also have a goal of boosting climate resilience in agriculture and water and health. So these are India's government determined concentration, nationally determined concentration target level. Okay? So let's look at where India stands. In the fossil fuel, we have India depends on coal, 56%, gas, 49%, and others, 6%. In renewable energy, wind is top, 43%. We are generating in India. Solar is 10%. Hydroelectric is 16%, and other is 11%. So this is where we are in 2023. Okay? So renewable energy production by December 2024, we produce wind, solar, and hydro, and that many 48, 97.5 gigawatts of energy. Okay, so we have in India they're putting emphasis on renewable energy source. If you read through that, as of November 2024, the total fossil fuel installed capacity reached 210 gigawatts, marking an impressive 14.2% increase in this sector. Okay, so that's a good news. Okay, government is putting emphasis on renewable energy production. If you look at energy scenario in 2024, as of October 2024, renewable energy-based electricity generation capacity stands at 201.45 gigawatt, accounting for 46.3% of country's total installed capacity. Okay, so they are putting more effort into renewables in terms of wind farms and wind energy. Okay, and they are also slowly moving into solar energy. So let's look at some of the goals of Indian government. India's total renewable energy installed capacity surged year by year. The target is 1,200 gigawatts of solar and 400 gigawatts of wind by the year 2047. And then by 2030, the target is 500 gigawatt renewable energy capacity. And if you look at the solar, they're making great stride in solar energy. And in India, solar power capacity is increasing, and there is 97.86 gigawatt by 31st December 2024. The use of solar power is also necessary for India to achieve carbon neutrality. We are talking about putting less CO2, so we need to produce more solar energy. Again, if you look at as of November 2024, the nuclear reactors, in India, we have 24 nuclear reactors in operation in 8 different nuclear power plants with a total capacity of 8180 megawatt of electricity production. So nuclear power produces a total of 48 trillion terawatt per hour 2023, okay, contributing roughly 3% of energy production through nuclear energy source. So look at biofuels, which is the part of this workshop. Bioenergy installation grew by 4.7% in India, rising to 10.84 gigawatt. Ethanol production increased for 2024, 6.35 billion liters of ethanol produced in India, mostly by sugar cane, okay, producing sugar, okay, which is not the focus. We need to get the waste to make ethanol. Okay. And in India, we produce 1,151 million megaton of biogas and then compressed biogas. And the biofuel market in India is witnessing a rapid growth, really big growth in biofuel market because of blended gasoline. You need to put 10% ethanol in the gas you buy to, so there's the government mandate. So there is an increase in biofuel production. So biodiesel production is also increasing to be produced 225 million liters in last year in 2024. Okay. So let's look at some of the challenges and opportunities. Okay. So some of the good news is India is among the cheapest solar power producer in the world. If you look at Indian stand where it is compared to other countries. India also ranks 5th globally for onshore wind farms producing wind energy. So India already competitive in solar market. India has several other offshore offsetting natural advantage of other countries. Okay, so government is putting emphasis on solar and wind, which is really good news. And if you look at the hydrogen production, new energy, India can attain global leadership in hydrogen production. And also transmission length, this is the kilometer installed generation of, how many kilometers you need to pull the energy through, okay? So in India, they're very competitive in pricing renewable power. The headline difference in hydrogen generation cost seems low, and India is really at a good market. Hydrogen is very costly to transport. So the pipeline effort is, being put in there by the government. Natural gas, the value chain about to turn corner in India. Gas consumption is declined by 0.6%, according to some government report. And we are at an inflection point, and as a policy of environment has been very conducive. Additionally, we have infrastructure and value chain in place to make the natural gas also available. Because the emphasis on putting pipeline to end user, to your home, instead of buying cylinders. And so that infrastructure is coming in big cities. This is again the value chain. I can see the global LNG price is normalized. The price is kind of fluctuating, and it kind of normalized within standard range. And the growth in physical infrastructure, along with favorable government policy for global gas price, can result in India gas very competitive. Okay? So let's look at some of the global adoption of clean energy. So compared to other country, global climate release related policies gaining further traction. Directionally, green energy policy of India is aligned with global goals because India is a party to the United Nations Convention of reducing greenhouse gas. Solar value chain and hydrogen value chain is likely to achieve these goals. Okay. India also indeed walking the green talk. And if you look at these three graphs, renewable energy account for 92% of the capacity addition. So keep adding more renewable energy source in India, especially solar and wind. And the renewable solar power capacity is significant, shows significant growth. Share of renewable energy in total energy generation is improving rapidly. So India made really good progress in this sector. So if you look at the tailwind from government policies, India is on a convention of reducing greenhouse, we call that. So India has this Panchamrit strategy, which is five corner strategy. So by 2070, India will achieve the target of net zero emission. Carbon intensity of the economy would be reduced to less than 45% by 2030. By 2030, India will need 50% energy requirement from renewable energy source. Non-fossil energy capacity will reach 500 gigawatt by 2030, reduce total projected carbon emission by 1 billion ton. These are the 5 points that Indian government tried to achieve. And so what initiative the government is making? The government is making initiative to achieve this goal by green hydrogen mission. They wanted to also increase solar and wind, hydrogen production value chain. They want to emphasize ethanol blending in your gasoline, 10% ethanol blending. They're going to increase to 15% blending in 2026. Then they want to add biogas by anaerobic digestion process. And they want to also launch national clean energy mission. So these are all government initiatives to achieve UN goal of reducing greenhouse gas. Let's look at what else government is doing. There is a shift from energy deficiency to energy self-sufficiency. They wanted to reduce the oil dependency from other countries, increase the gas value chain, power value chain. Also, they want to increase. Okay, they set up goals. And they're also trying to implement it by emphasizing some new policies and initiatives Indian government is taking. They call it the self-sustainable, that's a Hindi word, I cannot pronounce. If you look at that, the self-sustainability goal, India among the largest and fastest growing energy market, and with a shift from combustion to electrification. India's natural advantage in green energy to result in India moving from energy deficiency to energy self-sufficiency. Okay. Energy self-sufficiency could also insulate government policies from price hike from other countries when you depend on it. And there is also stable policy combined with past under investment. And then also redeployment of cash flow from traditional energy into green energy. And also energy segment is underrepresented in broader market. Okay. So these are some of the Indian energy theme currently government is adopting. That shows some result. Okay, India is expected to be the fastest growing energy market in the world. You can see the big jump, the energy market in India compared to other countries. India also primary energy consumption of by fuel. If you look at it, there also the renewable is 68% projected to go up in India. Energy consumption directly compared to GDP. Okay, when your GDP goes up, your consumption goes up. And you can see that in the graph. In Indian GDP, year by year, it is going up. your energy demand is also high, your energy consumption is also high. Okay. So it's a good thing. Your economy is improving, your lifestyle is changing. So you have your energy demand keep increasing because of that. So these are some of the India's climate achievement under United Nations Convention of Climate Change Policy. If you look at that, according to Climate Change Performance Index, Denmark is #1, achieving reduction of CO2 emission. India ranked way up in there, okay? It's 7th Indian government policy to reduce CO2. Okay? The US ranked lower because greenhouse gas emission and government policy is not there because of change in government. Overall, India's greenhouse emission rate dropped faster than expected in the last 14 years because of renewable energy. So this is a good report. If you look at this report, Indian government is making great stride in improving renewable energy, so and also try to reduce the conventional energy use. So the takeaway points in this part of the presentation is India's renewable energy potential, green hydrogen strategy, and climate action plan drive its pivotal role in global energy transition. India is playing a big role globally. India aims for net zero by 2070 with 50% non-fossil electricity by 2030 and ranked 4th globally in renewable energy capacity. Okay. And with a holistic and all-inclusive approach, the Indian government can implement policy for the future of renewable energy to increase in India. I will have a positive impact in terms of less CO2 emission, and globally, India is up there, #4, okay, in reducing CO2. So I just, the first sector, I gave you a global view, and the second section I gave where India is standing. India is in the right direction, in my opinion, compared to US. US is going in the wrong direction. Okay. So India is doing a really good thing. So let's look at actually how they're doing in terms of bioethanol production. And what are the resources available in India in terms of agriculture, actually, for example, paddy, rice, how much rice straw is available, how much wheat straw is available, how you can make ethanol from that, from waste to energy. So let's look at challenges of 2G bioethanol production, which is lignocellulosic ethanol. You make ethanol from agriculture residue after they cut the crop, get the grains, and whatever left in the field, we are trying to make ethanol from it. If you look at India's crude oil imports accounts for 90% of domestic consumption, so we still import a lot of crude oil. India is a signatory to the Paris Agreement, so we have to reduce CO2 emission. So the only way you can do is reduce your oil use, increase your use of bioethanol to complete the loop. So when you use bioethanol, you're having a carbon cycle. CO2 is going in a cycle. Plant use CO2 more. Okay. So India is very committed to climate change goal. So they want to have integrated biorefineries. They want to increase use of agriculture residue to make biofuel, which is our 2G ethanol, second generation ethanol production. So why bioethanol? Again, the bioethanol blending program is very critical. Unlike biodiesel, where raw material availability is a serious concern, the feedstock for bioethanol is there because we produce food, right, for our consumption. So whatever left in the field, we have to find a way to economically produce ethanol. Okay. From the straw, wheat straw, rice straw, corn, cob, and all that. So agro residues are very attractive for second generation feedstock to make ethanol. Okay, that makes sense. We make crop, get the food, take the waste to make energy in the form of ethanol production. So the national policy on biofuels, these are the policies. If you read through it, biofuel categorized basic biofuels, which is first generation, which is coming from the grain and the sugar. The second generation is from the ag residue. So the government is emphasizing going for the second gen, even though right now we are producing ethanol from the sugar cane. We need to shift towards agriculture residue. So the policy encourages setting up a supply chain mechanism for biofuel and biodiesel production, and when give incentive to farmers and also set up small sector energy production in a regional scale. So if you look at bioethanol viability gap, we created incentive for 2G bioethanol production. There is so much money allocated, so many crore money allocated to the commercial scale and demonstration plants. Some of the plant already in production. In Pune, there's one up there running. The 1,800 crore allocated for supplying 12 commercial projects. The government is spending money on 2G ethanol production. Okay. And they also added more amendments to increase ethanol production from ag waste to allow more feedstock for production for biofuels, where to get it, how to make that feedstock available. And the main problem is transportation, because the farmers are scattered everywhere. So you need to have regional collection centers. You need to densify the residue because of the volume, right? You have a lot of straw. And how you transport them. So those are some technical challenges that need to be addressed. Let's look at bioethanol blending, which is a successful part of Indian government achievement. The 10% blend keep increasing, and you can see that gasoline consumption in billions of liters and ethanol production that meeting the demand from year by year. India is meeting their goal of blending 10% of ethanol in your gas that you put in your car. So we are meeting, we're not importing ethanol. In India, we're producing whatever demand we need. So year by year, your ethanol production keeps going up, okay? The blending rate, if you look at the green line, it keeps going up, okay? Again, at the same point, India achieved 10% ethanol blending target. 5 months ahead of their deadline they set up, saving 2.7 million metric tons of carbon emission because of adding 10% ethanol. They reduced the CO2 emission. $5.27 billion less spent on fossil fuel imports because you're adding 10% ethanol. You import less crude oil. $5.4 billion in additional revenue to farmers. Okay, you buy this from farmers, from sugarcane and other things. The farmers are benefiting. In May 2024, India achieved 15% ethanol blending target, and they're changing the policy to increase to 25% blending. So they are in the right direction. The government is setting policy and also implementing. They're not setting policy and sitting there. They're also implementing it and giving some incentives. If you look at bioethanol for ethanol blending, we are meeting the demand, and you can see most of the ethanol from ethanol blending comes from molasses, sugar cane, followed by cane juice, and then food grain. Okay. So we got to shift away from this to ag residue to make ethanol, which is 2G, second generation ethanol. Right now, it's a 1G plant. We are getting all from food crops. We need to shift away from that. That's the 1G feedstock. These are the feedstock. Currently, India is producing ethanol from sugarcane, molasses, the damaged food grains like broken rice, and also maize. Okay, and you can see how much they're producing in terms of feedstock and quantity of ethanol in terms of the feedstock, how much they're producing. These are some statistics out there. So the first generation is successful. India achieved the maturity in ethanol production in first generation. Now we need to move into second generation to make it more attractive. Again, ethanol demand projections, if you are using more into electric vehicle, if the overall low electric vehicle and high medium electric vehicle, how much ethanol demand projection in the future, okay? So it's a E10, E20 ethanol blend, 10%, 20% ethanol blend. Even if you use electric vehicle in the future, there is still need ethanol for the ethanol blend. So the market is still going to be up there. So you're not going to have 100% electric vehicle use. It's going to not happen all of a sudden. It's a gradual effort, right? Again, ethanol production capacity and feedstock availability for ethanol blend. If you look at some of the statistics, the source of ethanol from different sectors, from grain and sugar and existing capacity, you can see all the statistics available in government database. So most of them are molasses-based and grain-based ethanol. We are still in 1G. We need to shift away from 1G to 2G to make it more attractive, more economical, and less burning of crops and causing air pollution in Delhi and other places. So 2G bioethanol is the way to go. So you need to get the grain for the food consumption, and the waste, instead of burning, you should use it for ethanol production. And that's where the technology is right now. Technology is there. We need improvement in making it economically sustainable. Right now, the cost of production from 2G is still high compared to gasoline prices. So we need to improve by research efficiency of decreasing the price of ethanol production. The challenge in 2G is, if you look at plant fiber, it's made up of lignin, cellulose, and hemicellulose. Lignin holds the cellulose and hemicellulose. We need to have pre-treatment to remove the lignin, and you get the cellulose and hemicellulose release. And then you add enzyme to break cellulose and get glucose. And then you add other enzyme to break hemicellulose to release the pentose and hexoses, the 5-carbon, 6-carbon sugar. So once you get those pre-treatment and enzymatic hydrolysis, you get your sugar. And up to that point, you need new technology to make it economical. So once you get your sugar, the same plant, where the 1G plant, and a fermentation tank is the same. You get the sugar into the same tank you produce. So most of your research in the first phase of pre-treatment and enzymatic hydrolysis to make your sugar from the ag residue. Again, the problem now, we can improve the efficiency of production, but how we are going to ship, transport this residue to the factory, right? If you look at it, as I say, it is a bulky material and it's less dense, right? It's very bulky. It is not the economical way to transport this to the factory where you do the pre-treatment and get your sugar. So you need to densify this, or you should have a regional cooperative small pre-treatment plant, probably every. And so this is tons of rice straw available in every state. You can see the amount by tonnage in different color coded. And again, if you look at GIS map, Tamil Nadu is really good in biomass production. The data, a lot of rice is produced. And this is the rice straw, again, from region by region. And this is cotton stock, cotton availability. After cotton is harvested, how much biomass is still there that it could be used for ethanol production. This is sugarcane residue, which is sugarcane leaf litter. After they harvest sugarcane, leaf litter is burned. And also the bagasse in the factory. After they extract the sugar, there is called sugarcane bagasse, which is a leftover. So if you look at breakdown of state-wise, so from Uttar Pradesh all the way down, Tamil Nadu way up there, number 3. in terms of biomass generation, biomass consumption, biomass surplus availability. So this much is right now is waste that could be potentially used for ethanol production, okay, state by state. So we have Uttar Pradesh, Punjab, Tamil Nadu, Haryana, West Bengal, Maharashtra are the high biomass generation states in India. There are a lot of all this biomass available for ethanol production. Understanding feedstock variability. So we have different feedstocks. So you need to find out how much lignin, cellulose, hemicellulose out there. A lot of research has been done. This is from government statistics, from government information database. You can see the component of the biomass, cellulose, lignin, hemicellulose for different material, whether it is rice straw, wheat straw, bagasse, even peanuts, groundnut, is there. There is variability of how much cellulose, hemicellulose. So we need to kind of tailor-made pre-treatment for each straw, each biomass feedstock. Your pre-treatment has to be adjusted a little bit differently. Okay, it's not one technology that is fit for all the biomass. So because of feedstock variability. If you look at supply chain logistics, how you're going to transport them, this is the wrong way to transport. This is not efficient way to transport. You got to densify your biomass into pellets. So you have more carbon in the pellet, and then you take them and put them in the pre-treatment. Or you have more cooperatives in 100 villages that have one center. So somehow we had to, get this problem sorted out. Currently, this is how it's transported. That's not an economical way to transport your straw to make your ethanol. Okay. So how do you make ethanol? So you have to go through this step from 2G plant. You got to get your material available. Then you do the pre-treatment to release the lignin. Then you add enzyme to get the sugar released. And then you conventional fermentation tank and you ferment with the yeast and you produce ethanol. And that's the bottleneck is the pre-treatment and enzymatic saccharification step. It changes from feedstock to feedstock because of the variability in every feedstock. The cellulose and hemicellulose contents are different. Okay. So if you look at technology landscape, there is technology is not matured yet. The 2G generation is there's still a lot of research need to be addressed for India. Cost economic is for producing ethanol from feedstock is very promising. Okay, right now it's not promising because of transport, but more research need to be put in to solve the problem. The commercial plants 2G are not completely operational. There are a few demonstration plant, government funded one running and producing ethanol. It's not commercial plant out there in India. In the US there are, but not in India. So let's look at the plant that is up and running. 2G bioethanol plant under various stage of development. You can see the company name out there. You can see the what kind of status. So there are only a couple of them are operational. If you look at the plant in Kashipur, these are operational, but they're producing 1 million liter of ethanol from the agriculture residue. But most of them are planned, not even constructed. They are in planning stage. Okay, so we are in taking baby steps. And at some point we're going to make rapid progress, and hopefully we can make ethanol from ag residue, which is more economical than from grain and sugar cane. So the 2G technology is under development. As I said, the government incentives are there. The research output is not, there are only few places that are doing research in India. One of them is Center for Energy and Environmental Sustainability in Lucknow. They generated a model for 2G plant, and they also have a demonstration plant. They have a small 100 liter per day ethanol production from wheat straw and rice straw. Okay. And that's their schematic, how they do it, and how they achieve their target. And this is again from Lucknow Center for Biofuels, and that's what they're envisioning, that region by region you can make 2G ethanol. This is their pilot plant. You can see that developed in CSIR NIST in Trivandrum, adopted by Center for Energy and Environmental Sustainability. Again, it has this pre-treatment, saccharification stage, then fermentation, and ethanol production distillations. Okay. Where we are standing in 2G ethanol production, the ethanol blending is successful, but it's only 1G ethanol. The incentives and viability gap funding for 2G is government is putting serious effort. Again, as I said, newer technologies are needed. 2G is not matured yet and not economically viable. Let's look at what the government is doing for 2G support in terms of they want to have a smart Samrat scheme they want to develop, promote natural farming, leading to changes in crop residue ratio to increase more residue ratio, and also want to increase importance of decentralized renewable energy system. You want to have regional cooperative in place of transportation. Ease of logistic across all modes of biomass supply chain. They're trying to do that. And transition to circular economy, extra income to farmers. That's a beneficial for selling their straw material, and levy on unblended fuel. So that increase the revenue, and promotion of agroforestry to have your biomass and feedstock available for ethanol production. So these are some of those concepts that government is adopting to increase your 2G ethanol production. So some of the global energy slides I got from Dr. Zappi and Ashok Pandey from Lucknow. I got some Indian statistical biofuel status. Okay. So I will end here. I'll take any questions if you have. Otherwise, I know it's a lot of information, a lot of statistics, I'm talking about a lot of energy source from conventional to, future biofuel source. There's a lot of that shows how different countries using. But this is coming hopefully to the so this is yeah. Yeah, the digestate is the main bottleneck because once you put this pre-treatment and enzymatic hydrolysis, you produce this liquor that is really, really, we call the digestate. It's hard to handle. Okay, so the way to solve in the US, what they did was they adopted a one pre-treatment method that works called ammonium fiber expansion method. We don't have that problem because it's a technology you have to adapt. You have to heat your biomass and apply ammonia gas, which opens up the fibers, and you don't produce digestate. You don't produce any inhibitors. Okay, so that technology is adapted and commercially produced in U.S. Okay. Yeah, that's why I said we need more research. That's why solve the problem of addressing the digestate issue, what pre-treatment you need to choose. And also the large scale, I addressed the transportation and all that. There's a lot of logistics, a lot of research need to be addressed. That's why this field is important, and you guys have to work on that in the future. Yes, yeah. We can address the digestate adapting to the US technology. I don't know whether that's commercially appropriate for India. In India, you need to adapt whether go for weak acid treatment or alkaline treatment or ionic liquid. So yeah, that's where the research comes into play. You got to work with it and try to address the digestate issue, try to address the transportation problem, all that. Okay, that's a good question. Yeah, digestate is a major one I heard in Indian scenario. Any other questions? Yeah. Hydrogen, yeah. Yeah. Yeah, hydrogen is a more efficient, no polluting energy source. Again, it's a supply chain and government policy issue. In US and California, they tried to have the hydrogen filling stations. Then government changed, policy changed. So I don't want it to, get in trouble. But the current government in the US is really bad in terms of green green energy. They completely block it. I mean, I don't know whether you heard the recent news. They shut down what California initiative of hydrogen supply chain there, and also in California are going to ban gasoline car in the year 2030. Governor produced, issued the order and the policy, everything in place, and some government games, and they completely shut it down. So, yeah, that's an issue. So that's beyond our control as scientists. So hydrogen it can be done. It's government issues and policies and supply chain. India is making great stride in hydrogen currently, and hopefully. My only problem is government change. You need to have all energy all the time. You don't want to prefer one or the other. If a left-leaning government go green energy, right-leaning government go into conventional energy, that's what's happening in the U.S. Right now, anything green, they're shutting it down in the U.S., which is not good. So in India, it's like all energy all the time, and they're putting effort to all energy. So that's really good. Okay. So hopefully hydrogen will pick up, and maybe you guys will take a lead. Okay. Yeah, yeah. Yeah, yeah, yeah. I mean, if you look at Brazil model, in Brazil is E85. Yeah, ethanol is 85% ethanol in all the cars in Brazil. And they find a way to decrease gasoline consumption. Okay. So you have to have a specialized engine for E85. Yeah, 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 yeah.
previous engines was not successful, that the demand is already coming from the industry. The product became much industry.
Yeah.
So what exactly like the technique will come into play? Or once the fitting increase.
Yeah. Okay. Yeah.
There's an extra amount of.
Yeah.
That be a bottleneck for the research.
I think if you look at US model, up to 20% blending, there is acceptable. There's no problem. Anything more than that, yeah, you need to have specialized engine, specialized, incentive for automakers to do that. Like Brazil, they're very, very serious about it. So I've been to Brazil, I'd seen it, it's working there, and they only put 15% of blend gasoline, 85% is ethanol in Brazil. So it can be done, but again, it's you have to work with the automotive industries and fuel industries to find a way. And Brazil has done it. Yeah. In US, we have introduced E85 engine, but there is internet. We have the conspiracy thing kind of floating around, and people now saying the ethanol blended fuel is going to, corrode your engine, and there is kind of that news out there, and it's kind of once it's out there, in the internet, it's hard for to change the mind, and so that failed in the E85 in US failed, and mostly it's E20, E25 right now. So. And in India, you got 15%, and they're going to 25%. Yeah, that's good. But yeah, again, it's work with the automotive industries. All right. Yeah. 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 The couple of ways to show that is your production of conventional fuel is going to decrease because of your blending, right? You're putting more biodiesel, so you put less crude use on it. That will have less emission. So that's the only way to convince through environmental issues. Yeah, you're putting less crude when you use blending. All right. So in the long run, it's going to have less emission, and also you have crude will last longer. Instead of put 100% crude, you put 80% crude, and you'll have the crude last longer. Otherwise, you're going to run out of crude. So those are the viewpoint on the environment you can try to convince. Okay. Yeah, we have the jargon environmental friendly, and then you had to explain it. Yeah, how it is environmental. Yeah, which is the what? Yeah, yeah. I mean, that's mainly the concentration in the blend is less. Your crude is less in the blended one compared to non-blended one. So as a result, your degradation is faster because you put less crude in the first place. So that's the ratio. Yeah. I mean, also when you blend, you only have a natural product, the bacteria in the environment will degrade it faster because they already have evolutionary mechanism to have the enzyme to degrade them compared to the crude oil. So yeah, so those are a couple of points you can address. Okay. All right. Thank you very much for patiently listening. As 90 minutes is too much in a lecture, but don't worry, we'll give a PowerPoint to everybody. Okay, so you could use the slides.